First part of your homework. Corrections of Unit 1 test. Yep, due tomorrow.
Oh, I didn't show you that. I did corrections.
That's congratulations. Hand them to me sometime. They always count, especially when they're homework. Corrections of Unit 1 test. Hand them in tomorrow. Okay, moving on though. You've had a bunch of time to think about the questions that I gave to you at the beginning of class. Which ones are you still stuck on, or like some clarification on, or some arbitration on? Valence.
The last one?
47?
Yep.
So that tells you have a rectangular box with square base, right? An open top. That one?
Yeah.
So you have a square base, so it's x and x. There's that back one, right? Do you know what the height is? No. If I just gave you this shape and I said, what's the volume? What would you say the volume is? X, length times width times height. In this case, it's x squared times h. Do we know what the volume is? So we know that x squared h is equal to 2. So that's the first thing we know. If I asked you to write the surface area in terms of x and h, what is the surface area in terms of x and h? Can someone raise their hand and tell me? How many faces are there, Gare? How many faces? There's 5. The base is? And the other ones are? So there's 4 of them. Exactly. You want this, but what's the problem? You've got h in there. You don't like that. So you want to replace it. You need to replace it with something in terms of? X. We need to, we have that relationship already. We have this relationship, which helps us because we now know that h is equal to, which we can then throw up there and end up with the surface area just in terms of x is x squared plus 4x times 2 over x squared, and that simplifies to 8 over what? X. So there's our surface area x. That's nice. That does answer the question. Let's go further, though. That is the surface area just in terms of x. Furia, put that away. You pay attention to this. What's the domain? If I just gave you this function, I said, what's the domain? Can someone raise their hand and tell me what the domain of this function is? What's the domain? Solnit.
Wouldn't it be positive numbers?
Nope.
Well, it would be positive, but then I don't know where the...
What's the domain of this function?
Yeah.
Done. That is the domain of that function. In terms of this problem, though, what's the effective domain? Meaning, what's the realistic domain of this? X such that x is larger than 0. Is there any limit to how big x can be? No, because the bigger x gets, the bigger the base gets, what happens to the height? So could this box still be 2 cubic meters and still be 1 billion miles by 1 billion miles? Yeah, because it'd be like a micro atom high, right? Okay, that's the effective domain. So that's one question we could ask. If we were making this box, if we were actually putting it together into a factory, we wanted to make it have 2 cubic meters. Oh, it fell. That's too bad. Did a shark ever fall from the sky?
X over X.
So, the question is, if you were making this box and you had to make it 2 meters cubed, what would it be nice to know? Okay, when you're making something and you want to maximize profits, you usually want to minimize what?
Surface area.
Why do we want to minimize surface area?
Because if you have to use less material.
Exactly, it minimizes the price of making the object. So let's try to minimize surface area. So we have our surface area function. Is that linear? No. Is that quadratic? It is?
I don't know.
Look at the function, not at my awesome beard, and just tell me here. Is it a quadratic? Why not?
So 2x squared?
Why isn't it a quadratic? No simplifying. Just tell me why. Let's look at it.
In the form
Thank you. That's exactly it. If it's this form, it's a quadratic. Is that in that form? No. This term messes it all up. Even if it was a quadratic, you could find the vertex, and that would be the minimum. But this isn't quadratic, so what are you going to have to use because you haven't taken calculus yet? You're going to have to graph it. Let's let it freak out a little bit. So we graph this. Oh, look at this. It's already there. Imagine that. Oh, there it is. Oh, wow. Cool. If you actually extend this window and make it -10 and graph this, there is another side to it. It goes down first and then up because the function is defined for x being negative. But is the realistic domain, does that allow it to be negative? No. Because x, what is the x-axis? That represents the length of what? The base, the length of the base, the square base, right? Technically, you can have a negative base, but in terms of the function, can you? Sure. Doesn't the answer doesn't make any sense though. So you really just want to look at the place where x is positive. So let's change that window back, and we graph this, and we're interested in that minimum. How do we go about finding the minimum? Second tray. So calc minimum, and it asks you for a left of it. That's right. Make sure you go to the left, not too far. Go to the right. And it asks you for a guess. You hit enter, and that's what it gives you. So let's talk about what those mean, those numbers mean. What's the x value represent? We already said it. The x is the what? The base? The length of the base. The x coordinate here represents the length of the base when surface area is minimized. What does this represent? Nope. That's the that's the minimal what? Surface area.
Isn't that number the cube root of 2? No.
Ah, it does look familiar though, right? It looks like it's something you might have seen this. It's not a square root, I'll tell you that much. I'll show you where it comes from. So here's the thing. You have to use your calculator to get that number. This is what the work looks like in AP Calculus when you learn how to do this. You start with this function. You have your surface area function, and it equals, what was it? It was x squared plus 8 over x. That's the same thing as x squared plus 8x to the negative 1. Here's where the calculus comes into play. I'm not explaining what this is. I'm just going to show you what the notation looks like. Oh, it's not so you can understand it, so you just can see what it looks like. X equals what? Cube root of 4. If you go back to your calculator and do the cube root of 4, look what you end up with. 1.587401052. And what was the actual value? 1.5874003. Which the bottom one's the estimate, top one is the exact value. So that's what the exact answer is. So the for all intents and purposes, the calculator is it pretty good at estimating? Could the calculator give you a better estimate if it wanted to?
No. Yeah, maybe.
Yeah, it could keep going. I mean, it thought for like a second and a half. In the internal programming in the calculator, if it went longer, do you think it could go even more accurate? Yeah, absolutely. You can actually get a more accurate answer if you zoom really, really far in. If you zoom really, 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 really far in and then run it, you'll get a better estimate. But that is what the calculus looks like. And if you take AP Calculus, actually, you do this. This would be something you do in the first month of applied calculus even. The universal constant on all maximums and minimums. What's the rate of change at a maximum and a minimum? 0. So what I did there, this right here is the rate of change function. I set the rate of change function equal to 0, and I solve for x. That's where the rate of change is 0, and that's where the minimum is going to occur. You'll do that a ton of times. In AP Calculus, if you ever get lost, do this. Set the derivative equal to 0 and solve. Remember that. It'll come up 100,000 times. Any other questions from the group you just did? Any other questions? Yeah. 46. Can you show me the...
This is also the same one that you did.
Yeah, I just got to see the question. Sorry. This is, find, express the surface area of a cube as a function of its volume. So if you have a cube, what's the volume of a cube in terms of its side length? The volume is x cubed. That's correct. Express the surface area. What's the volume? What's the surface area of a cube? It's 6 times
X squared.
But we want volume in terms of. We want the Sorry, this is not volume. Surface area in terms of. We have x instead, so we want to replace x with something something v, right? Well, we have a relationship here that tells us what does x equal. The third root of v, you then plug it in right there, and what do you end up with? The surface area is equal to 6 times, not x squared, but instead what do you have? Cube root of v.
That's it.
That's it.
Wow.
That's it.
And if,
That's it. And we'll talk about this. I mean, how many of you have dealt with exponents before? Fractional exponents? Cube root is what power?
negative.
What? 1/3. Cube root is the 1/3 power. So if you wanted to simplify this, this is v to the 1/3 squared. When you have powers of powers, what do? Do you remember? You multiply 6v to the 2/3. So if you ever wanted the surface area and you just had the volume of a cube, you would multiply 6 times the volume to the 2/3 power. Yes?
For example, I wanted to express, I was looking at it to get x squared from x third over x. X third is already v.
I'm sorry, what?
Like,
You see, I'm trying to get x squared in terms of volume. And I already know that.
Oh, if you want to get x squared in terms of volume? Okay, so you're asking this. That's a little tricky. Okay, so you have volume equals x cubed like this.
Yeah.
If you want to get x squared, what power do you have to raise it to?
well, can you just like, over 2/3?
How can I explain that?
Oh, you're going the other direction?
Yeah.
Oh, I see what you're doing. You did this, if I'm understanding you. So you know that surface area is equal to 6x squared. So x squared is equal to 6 over... So surface area, sorry. Surface area over 6. And then you also knew that v equals x times x times x, which is v is x squared times x. So you took this and plugged it in right there. So you have volume is equal to surface area over 6 times what? Times x. So you wanted that right there? So solve for what?
So for
Surface area?
surface area, it was 6 times volume over the root of volume but to the third.
I'll check this. There's something a little off. Okay, hold on. Your homework, everybody, is also to make sure you fully understand the class problems. Hold on.